everyone once again. Today we have a question from aerodynamics point of reference. Once again we have a question from the aerodynamic point of reference. Now let's read through the question given to us today. A bullet is to be tested in the laboratory to determine the drag force on it. The drag force D depends on the velocity of the bullet V and the length L, the density of the fluid rho, and the absolute viscosity of the fluid mu. Now calculate the non-dimensional pi, that is, by using Buckingham Pi theory, calculate the non-dimensional pi times involving d, that is the drag, and the mu, which is the viscosity, as non-repeating variables. That is, by using Buckingham Pi theory, that we should calculate the pi times involving the whole equation of the aerodynamics of the bullet, involving d, which is the drag, and mu, which is viscosity, as non-repeating variable. Now, by using Buckingham Pi theory, which is pi 1 and pi 2, how do we approach this particular question? Now, our drag equation is ml over t squared, and our velocity is L over t, and our density is L over L raised to power 3, and our mu, which is viscosity, is m over Lt. These are dimensional equation of all the parameters given. Now, by using the same dimensional parameters, as we were given to know that the drag should be non-repeating variables, so therefore our pi 1 by using Buckingham Pi becomes d v raised to power a L raised to power b mu rho raised to power c, as d is non-repeating, that is the drag is not repeating, so it's not carrying any power. So therefore, by transforming it into the pi times, it becomes this particular value. From there we can integrate the power series into algebra to the value inside the bracket. So therefore, from there we can notify that our m equals 1 plus c equals 0. Therefore, c becomes minus 1. Then from there we can integrate L, which is the length, equals 1 plus a plus b minus 3c equals 0. From there our c becomes 2. Also, likewise t, from there we can integrate that our t is negative 2 minus a equals 0. So therefore a equals negative 2. So therefore our pi terms y d is non-repeating becomes pi 1, because d v raised to power negative 2 L negative 2 rho negative 1. That gives us our pi 1 to be d over v square L square over rho. Now, the same application by applying it on when our mu, that is viscosity, is non-repeating value, just as we done for the first one our pi entries becomes this particular one. Also, our m equals -1 and our l equals -1. Our t equals -1. So therefore, our pi 2 times y mu, that is viscosity, is non-repeating, becomes this particular value. From there, therefore, our pi 2 equals mu over VL rho. So therefore, our 2 times pi theory becomes pi 1 equals d over v square L square over rho, and our pi 2 equals mu over VL rho. Thank you very much.